Hi, how are you doing today?
Hello, Hector. I'm doing well. Thank you for asking. Is there anything I can assist you with today?
Yes, I'd like to know what time is it right now?
The current time is 3:45 p.m. Is there anything else I can assist you with, Hector?
Can you please tell Atley to come and see me when he comes? Will you do that for me, please?
Of course, Hector. I will pass on the message to Aiken and make sure he comes to see you as soon as possible. Is there anything else I can assist you with?
The floor looks so not clean today. What's going on?
I apologize for any inconvenience. I will inform the cleaning staff to address this issue immediately. Is there anything else it can assist you with?
No, I think all is fine. Thank you very much. I'll see you then.
I am glad to hear that everything is okay. Have a great day.
Hey guys, how's it going? So I'd like to share my system design and how I was able to build that system. Most importantly, I'm gonna open source this project. But before doing that, I just want to walk you through the things that I'm going to be integrating in this system so that we can build a very, very powerful software at the end of the day. So just to kind of like brief you what the objective is, you can think of this as like my minimal system design that I just did. So we're building an AI receptionist, which we wanted to welcome guests if like these people are not on our system. So it should have some sort of like face recognition ability, right? So it should be able to recognize all the employees. If like this person does not exist, then that means they are new, and it should welcome them as guests. It should be able to take messages and leave messages and allow people to leave messages. That's what we did, right? Um, do all of these tasks. It should be able to schedule meetings for if people required that to do. So I'm going to get into how we're going to be able to make our large language model have these capabilities on its own. And we don't program anything. We just like train a model to be able to do all of the stuff, right? So that's what we're going to look into. So this is like the architecture at the high level. So the first thing that we have, you can think of this is you. So you kind of like speaking to this system, right? Like you, this is your speech, right? This is your voice. We're gonna have this speech recognition. So this has to recognize everything that the user has said, and it has to translate that to a text. This sounds very simple, but it's very, very hard. That's why we have like companies like AI Assembly, DeepGram, like a lot of services out there that try to achieve this goal. So the reason is difficult, especially in our case, is because the first problem that I'm thinking of is that how do we know that okay the user is starting to talk, right? Like the user is starting to talk. Are we gonna have this program, this server, right, to be listening continuously? If it's gonna do that, then we're gonna overwhelm ourselves because we're gonna have to all the time, every second, every millisecond, we have to be listening, and we have to then uh, detect if there's a word in that sound, right? This is not ideal. That's why you see a lot of people come up with solutions like Siri. So someone has to say Siri so that they can wake up the program, and the program can know that okay, someone is going to say something. Then now I can actually start to send this to the server, right? But I still want like to build it in such a way that someone does not have to do that, right? How can we think about that, right? So one way we can think about this is that we can say how about we build a very, very small model, very lightweight, that runs on the user device, right? It could be built with TensorFlow, right? So this is going to be more like a very, very small, like a real-time model that is going to be listening for a wake-up call, right? It's going to be listening for a wake-up wait, so to speak, something like Siri. So when the user says something that is Siri, we know that okay, the user want to speak to our AI receptionist, right? So we're gonna start processing it. So the reason I'm saying a very lightweight model that is going to listen is because we don't send anything to the server all the time. Everything is running on the user device. The only time we want to send something to the server is when the user has set Siri, and this model here that is running on the client side or on the local side of the user is going to be the one that actually let us know that okay, the user want to now speak with the AI, so we're going to have to send that to the server, right? So that's one way we can think about it. But what is another way? Another way we can do about it, which is a smart way, is that we can build a WebSocket server. So a WebSocket server, essentially, it's gonna allow us to have a bi-directional communication between the user and the server. So we can think of like we have this open connection, so the user can like literally send information and get responses from the server, just like that, right? That's cool. But the problem that I have with this is that essentially I want to get the audio data, all of it, because if I want to send it to the large language model so that the large language model can process it, right? So how can we do this? Because of when the user is gonna send the audio, yes, I want to send it in chunks because of it's gonna send in chunks as a WebSocket server. Then when it gets here, I don't want to send those chunks to the large language model. That is going to cause a problem because the large language model uses the attention mechanism. So I need context. I need what the user said, like everything that they said, so that I can understand how to respond to them. So if you're going to give me a word one by one, it's not going to make sense, right? So how can I achieve that? So one way we can do is that we can say, okay, cool, we can go with the WebSocket server because it's the most efficient in this case. Then what we can do is that we can build a buffer within our server. So this buffer is gonna say, I'm gonna receive all the audio from data as from the user as chunks, right? Then I'm gonna set it in the buffer. Then I'm gonna send that audio to the large language model, right? So this is what the user has said. So that's one way we can go about it, right? Then we can have some sort of like rules to say that okay, an audio must have this size, a specific size, like maybe it wouldn't make sense for someone to speak like for 3 minutes straight. Right? It wouldn't make sense, right? Because of they just want help from an AI. So it makes sense that someone would make short discussion. So that's one thing, right? So now, when it comes to the large language model, it obviously it did not get the audio, it got the text. That's the purpose of speech recognition. The speech recognition take the audio, turn it into text. Um, yeah, I've been saying audio, but sorry about that if I confuse you. But essentially, we're gonna get the audio, and we put it in the buffer, then we process it as one thing. We can actually process it like and save the text in the buffer. That's okay. That's fine also. Then we send the text to the large language model, right? So this text is what you said, is what the user said. Now the large language model is expecting the text, so that's good. So that's what it's gonna process. But before I continue with the large language model, I just want to say that essentially this system, this server that we're gonna build, um, I just want to raise like some important things that we're gonna do, right? So it's gonna run Whisper, which is an open AI model, but we're gonna run it using JAX, which is a numerical computing library that was built by Google. So it's very, very, very fast. So there's an open source project that was built on that. So, but this is just like wait. So we're gonna have to do like build the server and all of that and do all of this buffering and dynamic batching of these requests. So it's gonna be quite intense also from here. So I'm gonna build this with Rust. So it's gonna be something that I've been trying to learn, and yeah. So we're gonna try to do that. So there's gonna be I'm gonna leave a lot of details on how we're gonna build this server, but it's gonna be cool. Then what do we have? We have this large language model, right? So this is the large language model. So what I'm gonna do here is that we want the large language model to be able to do all the tasks on itself. Let's say you ask it to leave a message. We want it to know that okay, someone said I should someone left a message, so I'm gonna store that in some sort of like database. It could be a vector database, for instance, right? and this message was left by someone else. So we want the model to be able to do that on its own. So we don't want to like write if else statement. So that's where I'm gonna integrate. Um, I check out my video on Toolformer and Camelo. So I'm going to be using those research papers to build the language model with these capabilities to do those things. So that's what I'm going to be leveraging those research papers so that the model can be able to do all of the stuff. For instance, like the facial recognition, if like it has to like respond, it calls this facial recognition so that it recognizes the person who said all of this stuff, and so that it can respond with the name. Some you saw like with an example that I did. So we're using a facial recognition to do that. So, but the model has to kind of like use all of these tools. Check out my video on Toolformer. I think it's on my AI guy channel. So check it out. I explain all of this stuff and how it works in much detail. But yeah, essentially you can think of the storage, store all of the messages and facial recognition. These are more like tools that the model is going to use to respond to all the users. Then we have something interesting when it comes to the server of this model. So here we're going to use server side event, and the reason I'm using server side event is because essentially these models here are auto-regressive. So they kind of like produce tokens, one by one. So what we do is that we're gonna take the token as like the response, right? So we're gonna send it to the text to speech, so that text to speech can does not have to wait for the model to process the entire what is it response. So we already starting to respond to the user while we produce these tokens, right? This is an idea that is being used on Hugging Face text to text generation server. Check it out. I covered that video in much detail, and I explained the ideas what they used. But that's what we're gonna be doing. Then we have text to speech, which is going to be another service. But here, this is not actually hard. The only hard part is that if you're going to use a large language model, and the reason you want to use that is because you want to do something like cloning. So by cloning is that essentially you want the voice of like the avatar, like the person that you saw was speaking, to sound very good, like to sound like maybe very, very good, right? So you want to clone someone's voice so that they can sound like that person. So that's where you're gonna have a very large language model to do that, right? So it might be a little bit expensive for you to do that. But the good thing here is that we're also gonna have a server here, which is essentially gonna be taking all of these tokens that will be coming one by one, because we're gonna be using server send event, and they're gonna send these to NVIDIA. So this is NVIDIA avatar that you've seen here. So NVIDIA avatar, essentially what's going on here is that we build a gRPC server. So this here essentially is streaming this audio to NVIDIA. So it's gonna stream all of the audio that we have from this text to speech to NVIDIA Avatar. So I'm gonna show you the code in a little bit, how this works. It's quite actually good to see it from the code also. So this person here, it's just like someone who just opens the mouth and close it, and that's it. But he does that based on like when we call this gRPC service, because of we have like some sort of like an audio, then it's going to be sent to this. But the thing that you saw when we started the video on the screen, yeah, it's just like someone speaking, but really in the background, that's the whole entire architecture that is happening. So that's like the goal. There's a lot of things that I might change, but like that's like the high level of architecture that I'm thinking of going about. The reason I'm doing it this way, the thing is, when I was building this, I was not happy with like some of the services that we have from different services, and like they did not like meet what I really wanted to do, and I've been quite. I wanted to learn Rust and build some services with Rust. So I think also this is a good opportunity to build a very powerful project integrating it with AI.